Hello everyone, in this video we are going to discuss about institutional repositories. Institutional repositories are digital platforms that collect, preserve, and provide open access to the scholarly output of an institution, typically a university or research organization. These repositories often include research papers, theses, dissertations, datasets, and other academic materials. The goal is to enhance the visibility, accessibility, and impact of the institution's research while ensuring long-term preservation. Key features of institutional repositories. 1. Open access. They provide free access to scholarly work, promoting the dissemination of knowledge. 2. Preservation. They ensure long-term preservation of academic materials. 3. Content types. They store a variety of materials, such as articles, conference papers, books, multimedia, and sometimes learning materials. 4. Indexing. Many repositories are indexed by search engines like Google Scholar, making the work more discoverable. 5. Institutional identity. They highlight the research output specific to an institution, creating a cohesive archive. Well-known institutional repository platforms include DSpace, ePrints, Fedora Commons, Digital Commons. Institutional repositories often serve as a complement to traditional publishing, allowing scholars to share preprint or other versions of their work openly. DSpace. DSpace is an open-source digital repository software platform used by academic, non-profit, and commercial organizations to store, manage, and provide access to their digital research and scholarly materials. It was initially developed as a platform for institutional repositories to enable long-term access to research and educational content. DSpace supports a wide variety of digital content, including text, images, video, datasets, and more. DSpace infrastructure. DSpace is based on a three-tier architecture, which includes the following. 1. Storage layer. Responsible for storing digital objects, bit streams, and associated metadata. Supports different storage options, such as file systems or cloud-based storage. Metadata storage is typically handled by relational databases like PostgreSQL or Oracle. 2. Business logic layer. This layer includes core functionalities, such as content management, user roles and permissions, workflows, and curation. Provides services for content submission, approval, editing, and versioning. 3. Presentation layer. The user interface, UI, through which users can browse, search, and access content. Search techniques in DSpace. 1. Basic search. Keyword-based search that allows users to search across metadata fields and full text. 2. Advanced search. Allows users to refine searches by specific fields like author, title, subject, or date range. 3. Facet search. Provides filters like author, subject, date, or document type to narrow down search results. 4. Full text search. Enables searching within the full text of documents if full text indexing is enabled. Advantages of DSpace. 1. Open source. Free to use, modify, and distribute, which provides cost savings for institutions. 2. Customization. Highly customizable UI and workflows to fit the needs of different institutions. 3. Community support. Large, active global community that contributes to the software's development and provides support. Disadvantages of DSpace. 1. Complex customization. Customizing the interface or adding new functionality can be technically complex and requires in-depth knowledge of DSpace architecture. 2. High maintenance. Regular updates, security patches, and system optimization may require dedicated staff. 3. Performance. Performance might degrade with very large repositories if not properly configured or scaled, especially with full-text search indexing. Next we will see a detailed video about DSpace.
Welcome to this introduction to DSpace. Originally developed by HP and MIT, DSpace is the software of choice for academic, non-profit, and commercial organizations building open digital repositories. The open-source software application DSpace now offers a comprehensive solution for your organization to manage, provide access to, preserve, and share your digital assets. DSpace preserves and enables easy and open access to all types of digital content, including text, images, moving images, audio, and datasets. The software is free, easy to install out of the box and is completely customizable to fit the needs of any organization. Currently, nearly 500 preeminent research institutions worldwide use DSpace and form a large community of users and enthusiasts. Together with a group of motivated developers, often affiliated to a specific institution, they ensure development and support in the long term. The DSpace open source platform was built on the concept of open knowledge sharing and long-term preservation. Organizations such as universities, museums, research labs and commercial institutions are using DSpace to create their own repositories and share their research output with the world. Institutions use DSpace for a variety of different content types. Aside from electronic theses, dissertations and scientific publications, you can also access art collections, cultural heritage resources, or audio and video clips. Let's now take a closer look at some of the ways administrators and users actually use DSpace. The software can be installed and configured in less than a day if you use the standard setup on a regular Linux or Windows server. Administrators can easily create a hierarchy of communities and collections. Communities typically represent departments, which are areas of research within an institution. Collections are subsets of communities. Responsibilities for reviewing incoming content can be delegated to different people for every collection. Once our administrator has created a community and collection, registered users can start submitting content to a collection. During the submission process, a user is presented with a series of mandatory and optional fields to complete, known as the item's metadata. These fields can be fully customized by the administrator and can differ from collection to collection. Standard metadata fields would include author, title, and abstract, for example. The full set of Dublin core fields is a part of the standard configuration. However, mets, mods, and other standards can easily be implemented. After completing the description, the user can choose one or more files to attach to the item, together with a description for each file. In the very last step, the user needs to accept the collection's license. These licenses can also be customized by the administrator and make it very clear for users to what extent the submitted information is being distributed. After a collections editor reviews the submitted description and files, the item will appear in the collection. It also becomes immediately accessible through the DSpace browse and search functions. Browsing the communities and collections will show you the structure of the repository. Every community and collection has a home page offering relevant contextual information. There are also options to browse the content by different indexes, including title, date, and author. The simple search page offers a Google-like search interface, displaying the results sorted by relevance. Advanced search allows you to specify which fields should contain specific words or sentences. Most search engines, such as Google, keep a close eye on publicly available DSpace sites. This means any information in your repository that is publicly available is indexed by all popular search engines and therefore can be found easily through keyword search. In some cases, more than 60% of the repository's visitors arrive through a search engine. Even after 6 years of intense development, DSpace continues to evolve to meet the ever-changing needs of the community and to take advantage of new technologies and web-based services. From preserving endangered Afghani manuscripts to creating virtual museums, organizations are pioneering ways DSpace can be used for a wide variety of purposes. The DSpace Foundation brings together a diverse group of organizations from over 50 countries. The role of the foundation is to lead the collaborative development of the software for the global community, enabling innovation and services for access, stewardship, and reuse of digital materials.